All right, so this is the work for our Chapter 6 test review for intermediate algebra. Hey guys. All right, some work through each of the problems, and hopefully this will work out exactly how we want it to. So, in the first problem here, you're told that the diameter of a certain bearing is 2 to the negative 5 inches, and we need to simplify this expression. So remember that 2 to the negative 5 means that you are going to have a fraction. So we did kind of do this a while back, but you take 2 to the negative 5 and you make it a positive by putting it in the bottom. So now you have 2 to the 5th. But of course, in order to say that it's in the bottom, you have to put a 1 up above, because otherwise you don't have a denominator. So now I've got a 1 above the 2 to the 5th, and that's kind of the positive exponent form. But then, of course, we want to simplify as much as possible. So that's what this is talking about here. So then we're going to actually evaluate what is 2 to the 5th. So 1 over, and 2 to the 2 squared would be 4, and then another 2 would be 8, and then another 2 would be 16, and then another 2 is 32. Remember that I don't want you to put this into decimal format, because that just means that you popped it into a calculator. Because you can do that. So in a calculator, you could just have it type 2 caret symbol negative 5, and it would have come out with the decimal version of 1 over 32. But again, we don't want to do that on the calculator. The idea is that you actually knew that it became a fraction and then 2 to the 5th. All right, so that was number 5. It also talks about it being a word problem, so there's also inches involved. Okay. Then in number 7 here, we're looking at negative 1 to the negative 4th. And so again, that negative exponent is going to become positive if you put it in the denominator. So it's still a negative 1, but now it's being raised to the positive 4 power. So if we raise that to the positive 4 power, the idea is that you are taking 1 over negative 1 times negative 1 times negative 1 times negative 1. And so these two multiplied would be positive 1. These two multiplied would be positive 1. And so technically you just have 1 over 1. And so our answer is just 1. All right, and of course you could have kind of messed that up if you forgot the parentheses and all of that. So make sure that you remember the negative means that just the power becomes positive, and then you have negative 1 times itself 4 times, which means 2 positive 1s multiplied, which is 1. All right, then this last one here has 10 to the negative 4th. This is actually kind of starting out with the scientific notation here. But either way, it's still 1 over 10 to the positive 4, because we got rid of that negative by putting a positive here. And then that means that it's actually 1 over 10 to the 4th. So that means that there are going to be 4 zeros. 1, 2, 3, 4. And then, of course, put your comma in the appropriate place. Again, this is also a decimal, but we're not looking for that. We're looking for the fraction. So on your test, it will say put it in fraction format. So there you go. All right. Then the next part says that you need to evaluate, and evaluate is really just meaning plug in. So you're going to take this 10 and you're going to plug it in for the b here. So if you rewrite the entire phrase as the 2/5 that's still there, but then times 10, because it used to be a b, and then bring that to the negative 4th. You can work on solving what's inside, because remember, order of operations says that you're going to do parentheses first. So if we go through the parentheses, that means I need to do 2/5 times 10. 2/5 times 10, you can just type into your calculator, but you can also do the fact that this is a fraction, multiply top times top and bottom times bottom. So you get 20/5 or 4. And so 4 is the result of this parenthesis idea, but then it's still being raised to the negative 4. So in that case, we actually have 1 over 4 to the positive 4. And then from there, our answer is going to be whatever 4 to the 4th is, which is, I believe, 196, but I'll check. 256. That's cool too. All right, so 256 is our denominator right there. All right. So again, we plugged in a b of 10, got the inner part, which is your parentheses of the order of operations, and got a 4. Then we're taking 4 and raising it to the -4, which really means in the denominator, and then 4 to the 4th is 256. That's your answer. All right, moving on. If you're going to simplify m to the -3, remember that simplify in this case just means write with a positive exponent. So if we're going to write it with positive exponents, that means that we have the idea that the negative becomes positive. So we want positive m to the 3rd. But of course, we can't say that it's in the bottom without having something in the numerator. And so we are going to put a 1 there. And so our simplification of this, again, because we just wrote with positive exponents, is at 1 over m to the positive 3. Alrighty. For some reason in the assignment, it says that this is a 2. So if we change all of that to a 2 and this to a 2, same idea. All right. Then the next problem here is number 15. And so you can see that we have this idea of, oh my gosh, there's a negative. But remember, if the negative is not as a power like these two, then that just stays the way that it is. All right. The other problem with this is that there's already a fraction here. And so when you're talking about moving these to the denominator, you can technically make this entire line a fraction. So really you're looking at -1, x to the -2 on top, y to the -4 on top, and then on the bottom there's a 2. So if these negatives are doing what they're supposed to do, then that means it's going to be positive by moving it down and positive by moving it down. So we're going to keep the -1 on top, 2 is still on bottom, but now these two are going to join the 2 on the bottom so that they can have positive exponents. Because again, simplifying just means rewrite it so that there are not any negative exponents. So our answer is negative out front. Remember, that could be on top or bottom, just one of them. So 1 on top, 2x squared y to the 4th. All right, then the next piece here says that we are going to have 3a, it's kind of hard to see, 3a to the positive 2, c to the -2, and a 4 on bottom with b to the 0. So if we take the time to work through this, notice that the only things that have exponents that are going to be doing anything new is this -2 and this 0. This a squared, this 3, this 4, nothing is happening with those because they don't have a negative exponent. So your a squared is going to stay on top, 4 is staying on bottom, but then this c to the -2 becomes c squared on the bottom. That b to the 0 is 1, and so if you want to, you can multiply by 1, but of course that's not necessarily important. Everything can be multiplied by 1. So your answer is then going to be 3 on top still, 4 on bottom, a squared left on top, and c squared on bottom. So you just moved one piece and eliminated the other because it was 1. All right, then moving on to simplifying this next expression. On the test, there will be an idea that you're going to write it in radical format first. And then from there, you're going to find the value as a number, as a digit or a number. So you need to show me that you know what this 1/2 means. And so hopefully you can remember or look back at your notes and you realize that this 1 is the power of the 81, but this 2 actually travels to be part of the root. So that means that the 2 is going to be out front, still have the root, still have 81, and it's to the first power. So again, that 2 used to be down here in the denominator. but then we had to move it out here because the whole idea is to understand what that half means. And that half means that there's a radical or a root. So in that case, we're really just finding out what is the square root of 81. Remember, if you don't write a number up here, it means it's assumed to be the square root. So square root of 81 is 9. So the two pieces that are going to be an answer for the test would be that your digit is 9, but then also that you rewrote the problem in that way. So the square root of 81 to the first is going to be the rewriting in radical format. Because remember that radical is just your roots, and roots are just your square root symbols, but there could be a number up there. All right, so when we take a look at the next one, notice that the 3 is in the denominator, and remember that that means that it is the value of the root. So if we rewrite it in radical format or with a root, you have a 3 root or third root of 64, and then that 2 stays the 64. So in that case, we are taking 64 squared and then cube rooted. So this would be one of the answers that you are going to be asked for on the test. So kind of step 1. But then we also went over the fact that this could also be, because of order of operations, the third root of 64 and all of that squared. The reason that you would ever want to do this is because now you can actually do it a little bit better in your head. You're asking what times itself 3 times makes 64, and then that smaller digit squared. Because if you do it this way, 64 squared is actually 4,096. And so then you're going to be asked to do the cube root of 4,096. And I don't know necessarily a lot of multiples of 4,096 in my head. So instead, if we go with the third root of 64, that means that you're going to have 4, and that quantity will be squared. So the third root of 64 is 4, but the square of 64 is this. And so either way, you're still going to end up with 16. But it is very hard to understand that 16 times 16 times 16 in your head is 4,096. So either way, the answer is still 16, but remember that this process kind of got you there without having to use too much of a calculator. So either way, both make 16. So your first answer in radical format, second answer as a digit. All right, then we're going to simplify each expression and make sure that all variables represent non-negative numbers, just because you cannot take the square root of a negative. So that's the concept that they're talking about right here. So we are assuming they're all positive, which we kind of would have done anyway. All right. So if we simplify each expression, this is going back to this idea here, but now instead of having the fraction, we're going to make the fraction. So we're taking this little tiny 5 that used to be here, and we're going to make it the denominator of this 10. So that means that we actually have z to the 10 over 5, and 10/5 is 2, so z squared. Another thing on the test is that it will say write it in fraction exponent format. So this is your fraction exponent format. And then, of course, this is just your simplified version. All right, and then over here, notice that there is no square on number 25, but it is there. It's assumed to be there. They never gave you the digit that this root actually is. So in this case, it's a square root, which means that this 8 is now going to have a denominator of 2, and this 6 is going to have a denominator of 2. So that means that we're going to be given 8 to x to the 8th divided by 2, and that'll be multiplied by y to the 6 over 2. And so simplifying 8 over 2, that makes x to the 4th, and simplifying y to the 6 over 2 makes y to the 3rd. So again, this would have been your fraction exponent answer, but then this would be your simplified result. All right, next piece. says to find the degree of each polynomial. So if we're going to find the degree of each polynomial, we look to the x value and we find its, or your variable, and find its power. So this one, since it doesn't have a variable, if it did, it would be to the power of 0. Because remember that previously in the other problem, we had something to the 0 power, this b, and that became a 1. And so if we wanted to keep 5 as 5, we'd multiply by 1, and then it would stay the same. So this is really just saying 5 times 1, which means that the degree is 0. So remember that all constants, that's what this is called, a constant has a degree of 0. Or you can remember that you can multiply everything by 1. Fancy form of 1 has x to the 0. Over here, it doesn't, again, matter what the variable is. It just matters what the power of the variable is. So this 3 is really great, except it's not the power. It's the 6, the small number that's there. So the degree for this guy is 6. All right. Moving on. And again, you can just check your answers on the attachment, but you can see these worked out if you were getting lost. All right, so remember that a polynomial just means that there are a bunch of terms that are being added or subtracted together. So in this case, we've got a term which is 2n, a term which is -4, and a term that's 3n squared. So if they want us to write the polynomial in standard form, that means that you are going to have the largest degree term to the smallest degree. So if we take a look at that, the largest degree is a 2. Remember, this one has a 0 like we just saw in the previous problem, and then this one actually has a 1. You're just not seeing it. Most students will think that this one actually has 0, but it's this one that has an x or a variable to the 0. So if we go through that, then then we have the first term, which is 3n squared, because that's the highest power. Then the next highest power is 2n, so I'll add that. And then the last power is just a 0, so -4. Don't forget that anytime you have a negative, it does attach to the number after it. So that's why our -4 is here and not -2n or something. So this is standard format. And then it says give the leading coefficient. So the leading coefficient, now that we have written it in standard form, is actually the leading number, not the leading power, but the leading number. So our leading coefficient, meaning out front, is 3. All right. Next ones, they want you to classify each polynomial according to its degree and number of terms. So we do have a notes section that I told you you'd need to remember about how you name each of these. So the first thing is to find the degree. So if we find the degree of number 33, it is a 1 because there's an s to the 1 and then technically an s to the 0. So the largest degree is the degree of the polynomial. Once we find its degree, we can also see how many terms there are. And there are 2 terms separated by that subtraction sign. So if we're going to name it based on its degree, a degree with a power of 1, hopefully you remember lines have a power of 1, so it's linear. And then from the number 2, that's when we come up with the word binomial. So the idea is that it could be a constant for degree 0, linear, quadratic, cubic, those are all the names of the powers. But then when it comes to terms, it's either monomial or binomial because it's 2, or trinomial, or then polynomial after that. So then we identify the same thing over here. So the degree of this one is going to be 4. It's already written in standard notation. And then there are 3 terms. So that means that since it's a 4th degree, we're going to be calling it a quartic. Remember that quart is because there are, for instance, 4 quarters in a dollar or 4 quarts in a gallon. So quartic for the number 4. And then terms, there are 3, and triangles have 3 angles. So trinomial is what we're looking at here. It's kind of the first and last name of that. All right, then we move on to adding and subtracting polynomials. This is where you are going to combine everything that has a like term, or alike terms. And remember that the way that something has an alike term is that it has the same variable. So if we take a look at what's happening here in number 37, you have a 3t and a negative 7t. Remember that negative goes with the thing after it. And then we have just a number, which is 5 in this case, and negative 2. So if we put them all together, you have 3 minus 7t, and you can always do 3t minus 7t and rewrite the whole thing. And then we also have plus a 5 and minus 2. And so the result of each of those is that it's 3t minus 7t, so negative 4t. Watch out for your negatives. And then the 5 minus 2 makes 3. So our result here is going to be negative 4t plus 3. That is the simplification of adding and subtracting. So you're always just looking for what things have the same powers, and then you just combine the term or the coefficient that's up front. So in this case, the highest one is 3, so I can put these two together. So negative 1h cubed and 4h cubed means that we are going to get 3h cubed in the end. The next set that goes together here is your negative 2h squared and a negative 1. Remember that 1 is there. H squared. So that makes negative 3h squared. And then the last one, just this constant here, doesn't have any other friends there. But either way, we add a 5 at the end. And that is our official standard format of adding and subtracting this polynomial. All right. Then in the next one, we don't have as much room, but hey, what you're going to do here is subtract these. So that means that everything after it actually has the opposite symbol. So if we rewrite this, we're going to have 12 plus 6p, but then I'm going to have negative p, positive p squared, and negative 4. Because if we distribute this negative, it means the opposite of all of the coefficients that are there. So we're going to subtract p, add a p squared, and subtract a 4. And now that we have it in the list like we do up above, no more parentheses, you can go ahead and just combine the like terms. So for instance, this p squared has that first power that we're looking for. Here's a negative p to the power of 1 and a 6p that could go with it. And then the last piece is the 4, that could also, negative 4, that could be put with this positive 12. So if we put them all together, I don't have a whole lot of room, the answer is going to be the p squared. The just power of p's, remember this is a negative p, so 6 minus 1p makes 5p. And then that last piece of negative 4 and 12 is going to come out to be an 8. So that is our result after subtracting. Same thing happens for this next one in number 43. All you're doing is, again, distributing that negative. Once you distribute that negative, it will look like a problem up here. And then once you have distributed, you combine all of the things that have the like terms. So technically, you'll have 10g minus g squared plus 3. And then from this distribution, you'll have positive 4g squared minus 8g plus 1. If we put together all of the terms that are alike, or circle them up, this one here, 4g squared and negative g squared are going to put together. We also are going to have negative 8g and 10g. And then the numbers that will go together is your 3 and 1. So if we put them all together, the g squared, it looks like there's negative 1 and 4. So we'll have 3 g squareds left. Then for the red ones here, negative 8 g's and 10 g's is going to make positive 2 g's. 10 minus 8 is 2. And then the last one, the numbers have a positive 3 and a positive 1. So we end up with positive 4. And that is our answer for that one. Moving on to number 45. If we multiply, it's different than adding because we can multiply any number with any number, of course, and any variable with any variable. In the previous ones with adding, you couldn't combine the variables, but now we can. So in that case, we're going to take 2r and 4r and multiply them. These parentheses don't actually make any difference. So technically, this is 2 times r times 4 times r. They would make a difference if there was a power, which there isn't in any of these. If there was maybe a squared up here or something. Then all you need to do is take your numbers and put them together. So 2 times 4 and r times r. And so we'll get 8r squared. And so your result is just 8r squared. So basically you're going to take all the numbers, multiply them, all the variables and multiply them and get your powers. Down here, this is when we're going to use our area model. So this next one, again, kind of tricky because, oh my gosh, they're negatives, but that's okay. So negative 3 times x times y times negative 6 times x squared times y. If we put them all together in a nice order, we're going to have negative 3 times negative 6, which will make positive 18. After that, we're going to have an x and an x squared. And so that means that you have 1x and 2 x's, so they're x cubed there. And then the last one is a y, again to the power of 1, times another y to the power of 1. And a number times a number, or sorry, a variable times a variable is going to just make that variable squared. So your answer is 18x to the third y squared. All right, this last piece here starts off on the distribution. So the idea is that you take this 2 and multiply it into each of these. The thing about multiplying into something that's just a variable is that you're just going to have it right next to it. So 2 times x squared isn't really going to change much. That's an ugly 2. All right, then you're going to have 2 times negative 4 x's. And then you're also going to have 2 times 6. So if we multiply that 2 into everything, you're left with a 2x squared. These two values become negative 8x's, and these two values become 12. So just doubling everything that you had there to begin with. All right, the next piece you may choose to use something called FOIL, but I tend to use this area model. So since there is a binomial, which means 2 terms, and another binomial, which is 2 terms, I'm going to make a 2 by 2 box. So 2 terms by 2 terms. Then each of them I'm going to take and label each column and each row. So a plus 3 is this first term. A minus 6 is the second term. So you just take each piece of the binomial and make it a column or a row. And so once you multiply, a times a makes a squared. A times 3 is just 3a. A times negative 6, again, just set them next to each other. And then negative 6 times 13 makes 18. So in total, you've got these 4 pieces, which is what you would get with FOIL as well. And so technically the answer is a squared plus 3a for here, minus 6a plus 18. But hopefully from the previous, we note that, hi.
Sorry.
That's okay.
Do you want anything from Chipotle?
Oh, no, we're good. So then we're going to combine, because we did in the previous section, the 3a and the minus 6a. A squared minus 3a plus 18. Woo. And so that trinomial is the result. All right, so we continue with the next ones. And again, they're both binomials multiplied by each other. So that just means that we're going to have a 2 by 2 box. And x and negative 10 from your first binomial, and x and negative 2 from your second binomial. The result of x times x is x squared, yay. And then negative 10x from this column and row negative 2x from this column and row, and then positive 20 from the last one. The idea is that you end up combining most of the time these diagonals. So if we put these together, we're going to have an x squared and a plus 20. But then in the middle, you're technically going to have the combination of negative 12 and x. All right. And then our last one here has some q's instead of x's, but we should be fine. So we just label our square as 2q for the first one and 6, and 4q and the second one of 5. If you put them all together, 2 times 4 is going to be 8q squared, because q times q is q squared. 4q times 6 makes 24 from the numbers, and then the q. And 10 from our numbers of 2 and 5 being multiplied, and a q. And then 30 from 5 times 6. What tends to happen is that once you've multiplied them, then you continue to multiply. And so you might think there are 240 q's here, but there are only 34 because we're adding them. So 34 q's, and then the 8q squareds, and the 30. All right. Moving on to the last 6 problems. This is our most recent chapter. And it's the same idea. You could use the formulas, or you could use the area model that we just did. So whichever one you feel more comfortable with, I'm going to use our formulas just so that we have that reference here. So this one here is the difference of the difference here. So our formula is that if you had an a minus b and it was squared, that you would end up with a squared minus 2ab plus b squared. And so if you know what your a is, you know what your b is, which in this case is a p and a 4, you can plug it into this formula. Of course, you can go back to the area model if you feel like it, but we're going to try the formulas here. This will help us when we're trying to go backwards later. All right, so taking a look at this, this means that our a is p and our b is 4. Be careful that you don't call your b negative 4 because the negative is already taken into with the formula. So if we have a minus b squared, that means that I'm going to have whatever my a value is squared minus 2 times that a value and that b value, and then I'm going to add b squared. So officially, if the a is p, then it's p squared. If the b is 4, that means that this is going to be 2 times p times 4. And then to that, I'm going to add 4 squared. So to kind of clean this up a little bit, p squared is our first term still. But then negative 2 times 4 with a p makes negative 8p. So again, this entire set here becomes 8p, negative 8p. And then we're going to add 16 to that. All right. Just a little side note, again, we could have gotten that from the same process that we did in the previous one, which was your area model. And so if we put p minus 4 here, and then the fact that it's squared, so p minus 4 again, we would get, just as we have above, p squared minus 4p, but then that would combine with this minus 4p, and then a positive 16. And so officially, you would have a p squared, negative 8p's, and a 16. So either way, you do have the same answer, but one of them uses the formula, which is a good technique, and then the other uses our area model from before. So if we keep going, this next one here uses a different formula, but this is just for a plus b squared. And a plus b squared leaves us with a squared plus 2ab plus b squared. So if we identify what our a is, in this case it's m, and our b, which is 6, we're going to fill in the formula as we did before, with the a being squared, 2 times the a times the b, and b squared. So filling that in, our a is m, so m squared, plus 2 times m, and then times the 6 that's there, plus a b, which is 6 squared. Again, cleaning this up a little bit, you get m squared plus 12m plus 36. So that's our result there. This next one here gets a little bit trickier because now instead of just a letter or a variable, a number, you have both of them. So that's just the quantity that we're going to have to square. So in this case, 2r is a, and then we've got the b as our 1, and that's going to be in the squared formula of subtraction. So maybe I'll go back to blue. So that means that it's going to be a squared minus 2ab plus b squared. And since our a value is 2r, that entire quantity needs to be squared. It's best if you use parentheses. Then we're going to subtract 2, and a is 2r. And our b is 1. Remember, not negative 1, because it was taken into account in the formula anyway. And then our b squared is going to be 1 squared, which you need to be very careful because 1 squared is not 2, even though we really want it to be. Then a little side note of 2r squared. Remember that r squared, squared means the same thing times the same thing. So it's technically 2r times 2r. So that's going to be 4r squared. So a lot of you would have just put 2r squared, but it is 4r squared. So remember to square the number as well. And then the combination of this is going to make negative 2 times 1. So negative 4, and then an r still, and then plus 1 in the end from 1 squared. All right, moving on. This next one has the same idea as the previous, only now instead of an r, we have an n, and then instead of a 1, there's a 5. So same thing, and again, doing things multiple times does help you retain them. So in this case, we've got an a of 2n minus a b, and I'm going to do it a little bit faster this time, so I'm going to just fill it in as we go. It's a squared, so 2n squared. And then you're going to add subtract 2a from that, or 2ab. So we're going to subtract 2, and our a is 2n, and our b is 5. So putting those all in parentheses. And then we're going to add b squared, so 5 squared. Simplifying that up a little bit, remember that we're going to get 4n squared and not just 2n squared. And then 2 times 2 times 5 is going to make 20, but with a negative, because of the negative 2, n, and then 5 squared is 25. 4n squared minus 20n plus 25. All right, then this last piece we did have a formula for as well, so I'll write that up here. Anytime that you have a plus and a minus of the same thing, so we called it a plus b and a minus b, you're going to end up just with a squared minus. Minus b squared. So this, again, you can use the box for. You could have used the box for all of them. But all you would need to do is fill in the formula. Realize that your a value is x. Your b value is 1. And so when we put it into the formula of a squared minus, it's a very thick minus, minus b squared, you're going to get x squared minus 1 squared, which is just going to be x squared minus 1. What happens in the box is that these two diagonal terms are going to be opposites, and so they cancel. That's why there's only a binomial left. The last piece has a squared inside of it, so of course this is kind of a challenge problem, but the same thing applies. Your a is still c squared. Your b is still just d because of the fact that there's a plus and a minus here of the same exact thing. And so officially, you're going to have a squared plus b squared, which means c squared, because that was your a squared. And then you're going to, I really want that to be a plus, don't I? Minus the b squared, which is d. And then squaring something that's already squared, technically means you're multiplying, but if we look at it, it's c squared times c squared, or c written out 4 times. Run out of room there. So what you're going to result in here is c to the 4th minus your d squared. All right, so hopefully that helped you with each of the problems on the review. Of course, this will be scanned and you can look at that as well. But the idea is that you'd be ready for the online test. So good luck on the test tomorrow.